So we've looked at standard form for quadratics, which is x squared plus bx plus c, that whole one, the trinomials, the things you learn to factor, right? We remember this? We remember factoring from way back when? Yes? No? I'm getting a lot of blank stares. Yes? Do we remember factoring trinomials? Just the idea of a trinomial, having ax squared plus bx plus c, that format of equation. Okay, cool, that's all. And then we learned vertex form. Vertex form tells you about the vertex, right? And you can kind of easily identify it from the equation. The last form you're going to learn is called factored form, right? Which brings back factoring from the last unit. And it helps us identify where are we crossing the x-axis, right? The x-axis is this thing. Where are we crossing this line, right? Are we all good? We're on 4.5a. So this is our equation for factored form. It is y equals a, and then bracket x minus r, x minus s, where we're going to see r and s serve an important role in this equation. So, okay, same thing like we did with the other ones. If I'm given an equation and a table of values, we're going to just practice plotting those values into the chart, right? So I'm going to do, for -2, we're going to say y is equal to -2 plus 1, and then bracket -2 minus 3. Right? -2 plus 1, it's just -1. And then -2 minus 3, what does that give me? -5. The fact that these two things are in brackets beside each other means that you are multiplying these terms. So we're not adding them together, we are multiplying. Brackets insinuate multiplication. So -1 times -5 is just +5. And I'm going to keep repeating. So same thing. The only thing that's changing in this equation is the x. Everywhere where I see an x, I'm replacing it with this input. So -1 plus 1 and -1 minus 3. -1 plus 1? What happened there? What's that? 0, right? -1 plus 1 is just 0. And then I've got -1 minus 3, which is -4. Anything times 0 is 0. So this whole thing is just 0. Right? And I'm going to keep repeating. We've got 0 plus 1, 0 minus 3. Which 0 plus 1 is just 1. And then 0 minus 3, just -3. And I've got a positive times a negative. So 1 times -3 is just -3. Right? And as you see, I'm going to just keep repeating the same steps. The only thing that's changing is what I'm inputting. So this is going to give me 2. Oop, why did I do 0 again? There we go. 1. 2 and -2. So this will give me -4. Right? Is there anything about this that's like you kind of want to review or go over? Or is this kind of like straightforward? All that I'm doing is changing x. Is this okay? Okay. So even if I keep filling out this table, 2 plus 1, 3, 2 minus 3 is -1. So this gives me -3. You're going to see, oh, we've got some repeating values potentially. And 3 minus 3. Right? I get the same thing but reversed. 4 times 0 instead of 0 times 4. 1 times -3, 3 times -1. We're seeing kind of like a repeat here. And then last but not least, 4 plus 1 and 4 minus 3. That's going to give me 5 times 1, which is just 5. So we've got that symmetrical pattern happening about like here is when we see the values start to flip back to what they were. All right, and remember, these are coordinate points because some people got confused last time when we did a table on like, well, what's the point? This is your x value, this is your y value. We just showed the work on how we got the y value. Same thing, this is your x value, this is your y value. So that is what you're going to plot, right? So this is going to be at -2, 5. So I'm going horizontally to -2, and then I'm going up to 5, which I think we can just fit it here. Hello, good morning. Right, and I keep going. So same thing, -1, 0. I'm going horizontally to -1, and if I'm at 0, I don't have to move up or down because I'm on 0. Y is 0, so I am here. right? And then I keep going. 0, -3. 0 means I'm in the middle here. I have not shifted left or right, but I got to drop down 3. So I'll be down here. And then 1, -4. I'm going over to +1 and down 4. So I'll be here. And then you notice that's my lowest point. I don't go any lower than -4. I'm just going to now go back up again. So now all of these points are going to mirror. So now again, I'm at 2, -3. I'm at 3, 0. And I'm at 4, 5. Here, I'll grab it. Hi. No, I'm teaching. No worries. There we go. Okay, and that's enough. I can connect all these points. That's my parabola. Right, which again, it's going to be wonky. It's okay. That's more than enough. Okay. Where did I cross the x-axis? Where did I hit this line here? I hit it at 2 points. Yeah, Grace? -1 and 3, right? Which we can see here. At -1, I'm 0, right? If I go on top of this. And at 3, I'm also 0. That's where I cross. Good morning. Right, so your chart tells you by 0, but you can also see it on the graph there at -1 and at 3. Right, and we can even say here, x equals -1 and x equals 3. Those are my x-intercepts. Even if you want to write it as a coordinate point, that's totally okay too. Both are acceptable. And I think people did that on the test too. 3, 0. Okay, same thing. We've got a fraction in front. Don't let that scare you. We're just going to still do the same problem solving of like, okay, if I'm putting in 0, this is really going to be -½ times 0 - 2, 0 - 4. BEDMAS says I got to do brackets first, right? So I got to simplify like what's happening in here before I worry about this -½ in front. We'll worry about that after these things are multiplied, right? So this is going to be -1/2 times 0 - 2 is just -2, and then 0 - 4, -4, which then you can pop this all into a calculator, or you can see like, okay, first, covering this fraction, -2 times -4 gives me what? +8, and then +8 times -½, which like timesing by 1/2 is the same as like what? Dividing by 2, it's the exact same thing. So 8 divided by -2. What does that give me? Thank you, Evelyn. -4. And we repeat. Same thing. -½ 1 - 2, 1 - 4. So this is really like -1/2 times 1 - 2, -1, 1 - 4, -3. So again, this is like -1 times -3. +3, but then +3 divided by -2, that's going to be ugly. So that's going to be -3/2. Or if you want to write it as a decimal, that's just -1.5. Right, so I'm cool either fractions or decimals. Decimals I think are a little easier to like visualize on a graph, right? So here, I'll even just write -1.5. And we repeat. What's the next one going to be? Does someone want to finish the chart? Tara, did I entice you? No? Blair? Just doing the chart. Filling in the chart. That's okay. Does anyone want to? No? I don't want to volunteer anybody if they're not comfortable. But I just want to make sure that like this is okay. The idea of like plotting in values, because next we've got 2 - 2, 2 - 4. This is -½ times 2 - 2 is just 0. 2 - 4 is -2. Anything times 0, 0. So 0 times -2 is 0. 0 times -½ is still 0. So just 0 there. And I keep repeating. Right? So you might get decimals. That's okay. Right? Even on the test, some people were like, I'm getting an ugly number for A. It's allowed to be ugly. It's allowed to be a decimal. It's not always going to be like a super pretty parabola on even numbers. right? And 3 minus 4. So negative 1/2. And we've got 3 minus 2 is 1. And 3 minus 4 is negative 1. So we've got just positive 1/2. Do you guys want to try filling out the rest? While I talk to Zayden? Okay, I'm here, Jenny. Yeah. How far did we get? Do I gotta be speedy and catch up? Okay, same thing, negative 1/2. You can also, if you have the right calculator, like my Casio, you can do this whole statement all in one shot too. So this is gonna be 4 minus 2 and 4 minus 4, which 4 minus 4, what's that? 0, so the whole thing just goes to 0 again, right? So okay, I've got 0 and 0. I'm noticing maybe my y values are gonna start mirroring again. They're gonna start reflecting. 5 minus 2, 5 minus 4. This is going to give me negative 1/2 times 5 minus 2 is 3. 5 minus 4 is 1. So 3 and then divided by negative 2, same thing. This is going to be negative 1.5 again. Is it snowing? Is that what you're saying? Oh, I thought you were looking out the window because it's snowing. I was going to say, I don't want snow. I hate snow. This is going to give me 4 and negative 2. So same thing. Negative 8 divided by negative 2. That's going to give me positive 4. Or sorry. Yeah. This is positive 2. Not negative 2. So negative 4. Yeah, it would be negative 4. Because these two things are positive times a negative. We got all our points down? We're good? I'm going to go into plotting. Okay, peeps. If you got questions, ask me. So again, this is my x value. This is my y value. So this is going to be at 0, negative 4. So I know when x is equal to 0, I'm at negative 4. So I'm all the way down here. Right? And I keep going. At 1, I'm at negative 1.5. So like about here-ish, a little after 1, midpoint of that square. Right? I keep going. At 2, I'm at 0. Then 3, I'm at just a half. So just a little up. And then it looks like from there, that's my highest point. I'm just going to go back down now. So at 4, I'm crossing 0 again. At 5, I'm at negative 1.5, so here, and then at 6, I'm at negative 4 again. And look at that. There's our beautiful parabola. And I'm just going to connect these points now. Whee! Okay, more than enough. So then where did I cross this time? According to my chart or according to my graph, where did I cross? Yeah, Raph? At 2 and at 0, really close, which again, in our graph, 2 and 0 shows I got 0 as my output. That's my x-intercept. So we can write that here. What are the x-intercepts? This is going to be x equals 2, x equals 4. Or if you want to write it as a coordinate point, that's also okay. So 2, 0, and 4, 0. Right, so if we look at how did the equation tell us where the x-intercepts were going to be without graphing it, I would look at, okay, what was in my brackets? For the first one, I see I have x plus 1 and x minus 3. Hello. Yeah. Yeah, no worries. And your poppies are there too. Yeah, there's the next class. Okay, perfect. Right, I've got x plus 1 and x minus 3. I crossed at negative 1 and 3. Same thing here. I have x-intercepts at x minus 2, x minus 4. That's my brackets. and I crossed at 2 and 4. So what do you notice there?
It's the opposite equation.
It's like the opposite sign, right? So it's like saying that if we've got x minus r, or I'll even like put the a in front because we have an a value sometimes. It's the opposite. So for example, this bracket at 0, we're going to say that x is just equal to r. Ooh, not 2. And same thing with this one. At 0, this will be an x-intercept. And this is just going to be s is one option. R and S are just like placeholders. They're just like letters, just like how we use like A, H, and K. It's the opposite sign. You can think of that. Because like even here, we had -2 and -4, and we crossed at +2 and 4. Do you remember from vertex form how we said minus means I'm going in what direction? And plus means I'm going in another direction. Which one was which? X minus H meant I was going right or left? I was going to the right. So you can think x minus 2 means 2 units to the right, x minus 4, 4 units to the right, and there are my x-intercepts. If I've got plus means I'm going to the left. So I have to go to the left 1 unit and to the right 3 units. And look at that. To the left 1 unit, to the right 3 units. Right? So again, you can think about like minus and plus indicating direction rather than actual like value of your x-intercept. Or it's just going to be the opposite. If you can train your brain to look at the opposite and see x minus 2 means I'm crossing at 2. Right? So that's how they're related. Those are your x-intercepts. You can tell by just the equation where it's going to cross. Right? So that's it. That's all we're doing today. So if we're graphing, right, here are some steps that are going to make it a little easier for you. Immediately looking at the equation, you can identify the x-intercepts, right? Based on now we know the rule. R and S, and basically the signs are just flipped. Right? Using those, how can we find the vertex? We need to use an axis of symmetry equation, which I think is new. I don't think we've done that together, right? So the axis of symmetry equation is basically your x-intercepts will be basically the same distance from the vertex. So we have to find the average between them. So we're going to find the midpoint, and I'm going to show you how to do that, and that will tell us our vertex. So now that we have our 2 x-intercepts and a vertex, that's more than enough to connect, right? So let's try it out with this one. So, okay, I gotta sketch it, I gotta label the x-intercepts and the vertex. Off the bat, what are my x-intercepts gonna be? -6 and -2, right? You can say x equals -6 because we're flipping, x equals -2. So I can go ahead and plot those. Those are gonna be at -6, 0 and -2, 0, which is gonna be here, this is going by 2, so technically here, and all the way here. So it's all shifted on this side. Okay, now if I want to know where's my vertex, I know it's got to be in between here somewhere, but I don't know exactly. You could try eyeballing it, right? Or you can find that the AOS, or the x value of your vertex, right, is just going to be your first x-intercept plus your second x-intercept and divided by 2, right? Because that's the average distance. So I've got -6 plus -2, and I'm dividing by 2. Which, what does that give me? -6 plus -2 is -8, which then Alexandro says is just -4 if I divide by 2. So I know, okay, my x value of my vertex is at -4, but I don't know if I'm going up or if I'm going down. I can tell that this should open downwards because A is negative, so I should be frowning, right? But I don't know how high up to go. So once you have your axis of symmetry, to find what's your y value, or like where should I be plotting this vertex, we have to take this value and just plug it back into our original equation if I want to know what y is, right? So I can say y is equal to just -1 essentially times -4 plus 6 and -4 plus 2. And this is going to give me the negative on the outside. -4 plus 6 is just like 6 minus 4, or 2. And then -4 plus 2 is -2. So I've got 2 times -2, which is -4, but then I still have this minus in front. So negative 4 times negative 1, which gives me 4, positive 4, right? So therefore, our vertex is at negative 4, 4. That's my exact point. So find the AOS, that's your x value of the vertex, and then just plug it into your equation, and that'll tell you the y value. So I know I gotta be at negative 4, 4. That is enough for me to sketch. I don't need to do step pattern. If you would like to, you're more than welcome to, obviously. But this is more than enough for us to connect and then just draw. Ooh. I want to make that a little nicer. Voila. Right, that's our rough sketch. Okay. Would you like to try? Take the training wheels off and attempt this one? Yeah? Do you want to try it? Okay. Try it with this one. Again, step 1, identify your x-intercepts, do the AOS equation, plug it back into your original to find the y value. I'll even keep this up as the model.